Hello, this is Jim and Ben with DC Digital, and today we're demonstrating a DC-25N-T Down Up Static with PoE Powered. And I'm talking in reference to the first one that's up front. That is a master, and it is wirelessly sending out data to the secondaries. They are also 2.5-inch LEDs, and they are receiving the master's output. This is a Crestron or third-party receiving network card that receives data from a packet of data sent out TCP, and I'll have Ben go into showing you how that is all performed. But the master is also feeding back the same data that is sending the secondaries back to the controlling device, and the customer is using a Crestron controller, but any third-party device that can link to a communications port Ethernet wise can send these data packets. So I'm going to go ahead and have Ben describe what we do as far as testing and making sure that the product is correct, the packet sender that we send or that we use to send the data, and then it's up to the company that purchases this to set up their proprietary or what third-party controller to send the data via the network. So I'm going to go ahead and have Ben show you what's happening with the data and the performances and different variations. They're an up timer, they're a down timer, they're a time of day clock. You can send just random numbers to them. You can send blanks. You can control each digit, each number on each digit, up to 4 digits, obviously. These are 900 megahertz, so we are transmitting 900 megahertz, and outdoor is a 1500-foot range. Indoor we recommend 300-foot range, and these are low profile antennas that we have installed in them. As you can see, they're all PoE powered. The master is PoE and also controls the data or has the data. The secondaries are all just PoE powered. So without further ado, I'm going to go ahead and have Ben go over the controlling portion and the data sending.
Thank you.
You're welcome.
So this is the data portion is not going to change. There are some custom options here, but the data portion is largely the same. So this will apply to this product as a single standalone, as it also applies to a system like this. This device does host a web page, and you can access that by using IP setup to discover the device on the network. The MAC address is labeled right here on the back of the unit, and so you can find it by MAC address using this utility, and it's located at a specific web page, and then you can launch that web page right from the utility here by clicking that button. So this is what the home page looks like. You can test it using this string here, and the protocol is spelled out right here along with 8 different examples to kind of try and put it all together for you. I'm not going to go over this information on this page. I've got some examples I'll be going over. Then up here there's a tab for network setup. You can name the device whatever you want to see in your network configuration. You can also assign it either DHCP or static, and you can put your static IP address settings there. There's an additional setting that is what port it will listen to. So it will listen to data packets on port 23, and you can change that by changing this value here. You'll also need, since it is reporting back to data back to whatever one location, one IP address and port number, you want to spell that information out here. So I've got it set up using a utility called Packet Sender, and we'll send the link. We'll put a link in the description for Packet Sender and IP setup below the video. This is Packet Sender, and so this represents third-party software or third-party hardware or anything that somebody else has taken to send a data packet to this, and we'll use this to go through those examples. It is currently reporting up here that the IP address is .74 and the TCP packet is 57915. So we will make sure that that's what's in the settings here, 57915, and I think it's at 47. Is that right? 47. So we updated our IP address, looks like, and we'll submit that.
Just setting that display in a little closer, that master display, so they can see, you know, what is the result of.
Can you see the second one there, or
just there you go. Yep, perfect.
Move it up top.
Well, if you can set it behind is fine too.
Okay.
There you go.
Great. So this is also communicating back to the controller data, which I'll show you in a second, as well as broadcasting to those devices as well. So we'll go through some examples now. And you'll have to bear with me, I've got several examples here.
So you're working with the actual packet sending program.
Yes.
Whereas you were, if you go back one screen, that was the actual web page that the master is presenting.
Correct.
The DC digital.
This is the web server. Okay. This device has a web. It hosts this page and the network setup page.
Right.
It also communicates wirelessly to the secondaries. It communicates via TCP data packets to and from the third-party software. So it does all three of those things. So it's a working TCP, HTTP, and our proprietary wireless. So,
but you can send the code, the data from that text box in the top, or you can send it via what you're going to show us next.
Correct. Correct. You can. So these have been on since power up. They're just simply showing time of day. That's where they start from. If I want to put it into a static number, I just type in, following the protocol here, TS0 for no divider, and then 4 digits. So I'll just type in really quickly, capital T S0 1 2 3 4, enter, and I've got control of that device now. This uses the web service inside the host, whereas this will give us a little bit more of a direct control over how we send it. So we're going to send it on port 23. I've got all these commands already in here. We'll go back to time of day AM. So we're going to send this code TC10800, and there's the IP address, there's the port number, and that is the mode we're going to send. And we've already double checked our server configurations. So when we send this, we're opening a TCP connection and we're getting a response back. And the response back, let me expand this. The response back is, we got a clock and it's 8 o'clock. And there it is. And when this updates, it will send us another packet to update it, I think in a minute. Whenever this changes, it'll update this. This is AM 12-hour mode. This is PM 12-hour mode. No difference really. This is AM 24-hour mode, and you can set
put a timer, Ben.
PM 24-hour mode. That's all the clocks. So now we're going to go to up timer, and we're going to set it. We're going to start it at 0 and count up. And there you have it counting up, and you can see the secondaries are going along with it. And I'm actually going to change that to a persistent TCP connection. so that I can see this coming in persistently. It's broadcasting persistent, but I'm going to go ahead and send that again. It's going to open this window here. I'm going to click that to raw ASCII. So you see this is the command we sent, and then these are the packets that are coming back to the controller here as it updates. All right, and I'll just continue from this screen so that we simplify things. So this is an up timer, and we're going to go ahead and pause it, and we do that by sending just a 3-letter code, TU2, and it paused it in its countdown, and it's holding that value. And we're going to go ahead and resume it, and that's a TU3. Very simple commands here. Okay, there we go. TU3, and now it's counting up, incrementing again. And it does increment from, it does pause and resume from the milliseconds. And we'll go ahead and start from a downtimer position. So in a downtimer position, you might want to set a start value without counting down. And you can do that by sending one command, and this is all spelled out on that sheet. So it's now set to 1 minute, and it's holding, which you could resume that with the TD3 command to count from that position, or you can go ahead and send it a start command instead, where it sets to that value and starts, which is what I've just done. And you can see it counting down there. All right.
Okay.
Occasionally you'll see two timer values packetized together. That's just how the network works sometimes. That's not anything to do with the product.
Okay.
You want to see a static number?
Sure.
And blank? Okay.
A blank, yeah.
So you can blank the displays by sending out a decimal, a semicolon. So any position you put as a semicolon will blank the display. So there's completely blank, and it's still reporting back, but it's blank. And you can send like 2 numbers separated, and it would look like that. And again, it's reporting that all back here. So it pretty much works that way. It's just sending and feeding back between a third-party controller and the timers, broadcasting. And
very good. Yeah. So again, this is Ben and Jim with DC Digital, and we're demonstrating the DC-25N-T Down Up Static. It's a multifunction. It responds to network commands, strings that can be sent through via the web page, as Ben mentioned, and also a third-party device. And I think this specific customer is using a Crestron controller, and that it also is sending out wirelessly to secondaries. So really all you need is just one device in your building, if you want them all to be read redundantly, that you communicate to, and it resends out the data to those devices, and it'll be exactly what the master is.
this is going into a meeting room timer, so it might show
Okay.
time of day when
Good.
they're not holding meetings,
Right.
and
Or timer. Or
down timer as they're holding a meeting and they want to control the meeting flow, the speaking flow.
But you can pre-program all your functions to a speed button or something like that, to a quick in and go to it and do
Right,
it. Yeah.
a macro.
Macro, yeah. Again, this is Ben and Jim with DC Digital demonstrating these DC-25N, it's a network T down up static multifunction displays. Thanks for watching.